In the vast expanse of the universe, as portrayed in the beloved sci-fi series Star Trek, the crew of the USS Enterprise doesn't worry about running out of food or resources. They have the Replicator, a marvelous device that can materialize steak, Earl Grey tea, or even complex mechanical parts out of thin air. It's a brilliant vision, one that encapsulates the zenith of technological aspiration. Fast forward to today, and what once seemed like pure fiction is beginning to echo through the halls of our finest research institutions. Are we on the brink of turning Star Trek's fantasy into our reality? Let's explore this enthralling journey from imaginative scripts to tangible science. Before we continue, please take a moment to subscribe to my channel and share this video with your friends. It really helps a new channel with the algorithm, so I can continue to bring you interesting and often important videos for the shift to a better tomorrow. Back when colored TVs were a novelty, Star Trek introduced the world to technologies that were pure science fiction. Among these, the Replicator stood out as exceptionally revolutionary. It promised a future where hunger and material scarcity were problems of the past. In the show, this device operated on a level of advanced molecular nanotechnology, capable of rearranging subatomic particles, which were abundant everywhere in the universe, into objects and food at the command of the crew. The idea was not just to entertain, but to inspire. In subsequent series and films, the replicator technology was fleshed out, showcasing its use in not just culinary arts, but in manufacturing, medicine, and more. This broad spectrum highlighted an integrated vision of a future permeated by seamless, on-demand manufacturing. When Star Trek first aired, the concept of a replicator was purely imaginative. Yet it grounded itself on some real scientific principles, particularly those related to the conservation of mass, energy, and the manipulation of atoms at a granular level. Today, fields like 3D printing and molecular manufacturing are seen as nascent forms of the technology envisioned by the show. For instance, 3D printing, which initially started with plastics, now encompasses a range of materials including metals, concrete, and even living cells, suggesting a pathway to more complex forms of replication. However, despite significant advances, our disclosed capabilities are still miles away from the capabilities shown in Star Trek. According to what we have been told, the current technology cannot yet manipulate atoms with the precision or speed required. Nonetheless, a foundation has been set, making the fiction seem slightly more plausible to the people of the world. The leap from simple 3D printing to replicators involves not just technological advancements, but also philosophical and moral introspection. Some have concerns that, if you could replicate anything, there would be implications for economies based on scarcity copyright laws, or even human labor. The earliest thinkers who wrestled with these questions were not just scientists, but science fiction writers, philosophers, and futurists. They explored these ideas through fiction and theoretical discourse, laying the groundwork for our understanding of material replication and its societal impact. Understanding these philosophical debates helps in crafting policies and guiding research to ensure that if or when true replicators become a reality, they will be used ethically and wisely. Personally, I believe that a lack of scarcity is a good thing in a higher civilization than ours. If everyone could have what they wanted, there would be no crime. Society would stop judging people by what they have. Psychological issues would disappear. I simply don't understand deliberately creating scarcity for profit, which has been done to the people of the world for decades. Fast forward to recent innovations, and we find pioneering projects that push the boundaries closer to what was once fiction. Companies and research labs are developing printers that can output functional human tissues, and prototype matter compilers that hint at a future where atoms and molecules are assembled into precise configurations. These innovations may not have reached the capabilities of a Star Trek replicator yet, but they signify vital stepping stones. Each breakthrough in handling materials at a molecular level, each patent registered for nanoparticle manipulation, brings humanity closer to this once-dreamt reality. As we inch toward the realization of replication technologies, securing intellectual property rights has become crucial. Recent patents show a surge in technologies around advanced materials and methods of 3D printing, nanoparticle bonding, and bioassembly. Before proceeding, let's take a quick look at these currently patented technologies. First, 3D printing, also known as additive manufacturing, is a process of creating three-dimensional objects layer by layer from a digital model. In the context of replicators, 3D printing serves as a fundamental technology. Replicators could utilize advanced 3D printing techniques to construct objects on demand, ranging from simple tools to complex machinery. By integrating various materials and precise printing methods, replicators could fabricate items with intricate designs and tailored specifications quickly and efficiently. Nanoparticle bonding involves the joining together of nanoparticles, which are tiny particles with dimensions on the nanometer scale. This technology holds immense potential for replicators by enabling precise assembly at the molecular level. Replicators equipped with nanoparticle bonding capabilities could construct materials with exceptional strength, flexibility, and conductivity. They could fabricate objects with intricate internal structures and unique properties, revolutionizing fields such as materials science, electronics, and medicine. Bioassembly refers to the process of assembling biological materials, such as cells and tissues, into functional structures. In the context of replicators, bioassembly offers the ability to create living organisms or biological components. Replicators with bioassembly capabilities could produce organs for transplantation, create personalized medical treatments, or even generate synthetic life forms for various purposes. By harnessing the principles of biotechnology and tissue engineering, bioassembly-enabled replicators could revolutionize healthcare, biomanufacturing, and synthetic biology. These patented technologies are vivid predictors and roadmaps of future technological trajectories. Each patent reflects a step toward the ultimate goal of replication technology, and analyzing these can provide insights into where and how the technology might evolve. As replication technology moves from the realm of imagination to potential reality, it poses unique ethical and societal challenges. Some concerns include what will become of countries whose economies rely heavily on manufacturing when objects can be replicated at minimal cost anywhere? Or what are the implications for biodiversity if artificial replication replaces ecological processes? Addressing these questions is crucial as we navigate the uncharted waters of replication technology. Stakeholder engagements, public dialogues, and rigorous ethical reviews will be key to harnessing this technology's power responsibly. This dive into the world of replicators, from Star Trek's imaginative scripts to the cutting-edge labs where the seeds of these ideas are slowly taking root, shows us not just the power of creativity, but also the potential for science to turn fiction into reality. As we stand on this brink, the next chapters of this adventure will undoubtedly be as thrilling as they are unpredictable. In the vast expanse of the universe, as portrayed in the beloved sci-fi series Star Trek, the crew of the USS Enterprise doesn't worry about running out of food or resources. They have the Replicator, a marvelous device that can materialize steak, Earl Grey tea, or even complex mechanical parts out of thin air. It's a brilliant vision, one that encapsulates the zenith of technological aspiration. Fast forward to today, and what once seemed like pure fiction is beginning to echo through the halls of our finest research institutions. Are we on the brink of turning Star Trek's fantasy into our reality? Has this technology been suppressed, or are we receiving help from far-off evolved and benevolent civilizations? What are your thoughts? Are we about ready to go back to the future?